Hello and welcome to Lecture 17, Part 3 from Life in the Universe. In this video, we are going to conclude Unit F by taking a look at spacecraft exploration of the solar system, at least parts of it. Not going to include anything about manned exploration of the solar system here, just missions by robotic spacecraft to other planets. And this is actually an advantage we have in the solar system, and that unlike most of the universe where we're reliant on telescopes to learn about it, within the solar system we can, at quite a bit of effort and expense, send robotic spacecraft to go look at things up close. And so I'm going to take a little bit of a look at what's been done here. And I will tell you right now, I've got a lot of stuff here that's not in the notes because they're just basically tables of some of the missions. I'm going to talk about a few things in those tables, but I thought that you didn't necessarily need to have all that information in the notes. You can always look it up if you're interested. Anyway, it turns out there are three basic types of spacecraft missions you might do to another planet. Flybys, orbiters, or a lander. And I don't know, maybe the difference between a lander and a probe is a lander lands softly, a probe lands not softly. All right, so the cheapest thing to do is a flyby, and actually I'm going to get out of the share for a second to illustrate that. Let's say we're going to the planet Stapler, and if you want to send a spacecraft to fly by Stapler, then what it does is it just comes by Stapler, comes by at once and doesn't stop. And that means you've got a relatively limited period when you're close to the planet Stapler that you can make your observations up close, because not going to have a lot of advantage when you're far away either before or after. So it limits what you can do. But it has a significant advantage in that compared to the other two options, it's cheaper and easier. Okay. For an orbiter, your spacecraft comes in towards the planet Stapler, and you got to slow it down in order for Stapler's gravity to capture it. But then if it goes in orbit around Stapler, then you can spend a long time doing close-up observations from orbit, and in case maybe years. Whereas for a flyby, you might just have a few hours of prime observations. For you could have many, many years if your spacecraft keeps working of observations from orbit. For a lander, it's the hardest thing to do and therefore the most expensive. You've got to not only slow down, but you've got to land on the surface softly. And even with a roving lander, you can move around a little bit. You're not going to be able to explore much. So if you land here, you're not going to be able to come down here or over here. But at least you get some very close up, direct ability to analyze surface conditions, at least where you landed. All right, back to the share. Okay, so basically had all this, except one thing I didn't mention is, besides that direct measurement, leads to limited parts of the planetary surface or atmosphere. Sample returns are even one of the things you can do. There you go. So, oops, messing up here with the pen here. There you go. With sample returns, we have sample returns from the moon, both from manned mission and from unmanned missions. We have some little cometary samples. And anyway, with some asteroidal samples, including, if you pay attention to Science News, NASA spacecraft around an asteroid named Bennu that's going to be giving us a sample return, or at least it's going to be getting the sample relatively soon, be a while before it gets back here. All right, now, here's where we get the stuff that I didn't put in the lecture notes on the course website, but just kind of an overview of missions to other planets in the solar system, historically ongoing, and things that are sufficiently far along in planning where there's reasonable funding for them and are likely to actually happen. So what I've got for each one is I've got the name of the mission, the country that sent it. The dates will be date from launch until the termination of the phase of the mission related to that particular planet. Some missions have visited more than one object, so in some cases it will be a mission that would have gone on past that. Oops. The basic type of the mission, and then the status. So a green smiley face means that the mission was largely successful. An orange neutral face means that the mission had significant problems, but still got something out of it. And the red frowny face is an indication that the mission was essentially a complete failure. And so here's the first decade of trying to send spacecraft to Mars. And the 60s was a pretty unlucky decade for space exploration in general. Sputnik 1, the first artificial spacecraft of any type, was launched in 1957. So we're still trying to figure out how to do this at this time. This is why there's so many problems here. I will mention, given that on this one, that given that 57 was the first even satellite in Earth orbit, that the Russians tried Sputnik 24, launched only 5 years later, trying to land on Mars. That soon strikes me as being really, really optimistic. Things are a bit better in the 70s in general, although unfortunately the Russians have had a lot of bad luck with Mars. They've never had a complete success there, unfortunately. Honorable mention: Mars 6 is a lander that you see it got the neutral face. Mars 6 took some data on the way down to the surface. It landed, sent back the message that said, basically, I have landed, and that was the last that was ever heard from it. First successful landers on Mars were Viking 1 and 2 in the mid 70s. The orbiters lasting much longer than the landers did. That was really rousing success. And to date, although that will be changing soon, the Viking landers are the only missions to do explicitly astrobiological experiments on Mars. And in Unit M, I think it is, we'll talk a good bit about the experiments they did and the results. Let's see here. Oh, and let's see here. Going into the 90s, into the early 2000s, you'll notice that for some things launched in the 90s, there started to be, U.S. had some problems here. NASA had a philosophy during the 90s that they called faster, better, cheaper. You cannot have all three of those at the same time. At best, you can have two. You can do it faster and better, but not cheaper. You can do it faster and cheaper, but not better. Or you can do better and what would be better and cheaper, but not faster. You can't have all three at once. And eventually, NASA had kind of figured that out. Anyway, after 2000, when NASA dropped that approach, things have generally been better, including the first roving landers, which was first rover, I guess, was Mars Pathfinder, which did work pretty well, and Spirit and Opportunity, which were quite successful. And you notice that I said you can have orbiters working in particular for years. And notice we've got three orbiters here that have been anywhere from 15 to 19 years after launch that are still going fine. Going into a bit more recently, and this will include everything that has up until the latest round of launch, things have actually gotten to Mars. MSL Curiosity, currently the only functioning rover, but it's doing fine, along with some other orbiters. And notice that progressively more countries get involved in this. European Space Agency is a consortium of a number of Western European countries. India has a successful orbiter in orbit around Mars now. And so this is kind of where things are. And the most recent that have actually gotten to Mars. Mars and Earth are well positioned for launching to get there easily every 2 years. So our latest round of launches will get there in 2021. which will include the first attempt at a Chinese lander, which will be a rover type. And then this US mission, Perseverance is the landing rover, and then Ingenuity is a little drone helicopter that it will launch that'll fly around to get some aerial views around where it is. Anyway, all scheduled to arrive in 2021. Perseverance is carrying some specifically astrobiological experiments. So going to be very interesting to see what that comes up. And then the ExoMars lander and rover from joint ESA Russian mission, planning on launching at the next launch window in 2022, will be even we'll also have some astrobiological experiments. Notice also the United Arab Emirates have an orbiter on the way to Mars right now. And then you can see some of the future ideas, including some like Juice and Psyche will fly by Mars on their way somewhere else. But then some others that I think all of these are sufficiently well funded that they're realistically planned. All right. Venus had a lot of, as everything, had a lot of problems in the 60s. Although Russians have had better luck with Venus than they have with Mars, including getting into the 70s and 80s, some successful landers and successfully deploying balloons that floated around for a while into the upper Martian atmosphere. The US Magellan orbiter was also very important in that it gave us our best radar map of the surface of Venus. In terms of what is going on and kind of in the future, there are currently there's currently one orbiter in orbiting Venus, Japanese one called Akatsuki. I have it here as a neutral because its first attempt to go into orbit around Venus failed, but its orbit around the sun brought it close to Venus again, where it got another chance, and it worked on that time. Um, the Parker Solar Probe has done some flybys, doing a few more on its way to get is primarily a mission to study the sun, but it's flown by Venus in the process and has a few more flybys to do to get into its final orbit. Bepi Colombo is on its way to Mercury and it has completed its flybys. Has some flybys will be going elsewhere. And this Indian orbiter mission does look like it's got enough funding to count as realistic. This Venera D, this big Russian mission, uh, I take that with a big grain of salt. It's very ambitious with an orbiter, a lander, and a number of atmospheric balloons, but it's really hard to find much information about it. It seems like they're hardly updating the website for the mission, but about a year ago, there was a conference about it. So maybe it's going to really go, but maybe not. We'll see. All right. In the inner solar system, Mercury is the least studied uh, uh, planet. It has had Mariner 10 did 3 flybys in the 70s. Messenger did a series of flybys and then went into orbit for 4 years, quite successful mission. Bepi Colombo, it's on its way there with a pair of orbiters. And after doing one or more flybys, I don't think it's done any of the flybys yet, but in 2025, the orbiters will go into orbit. And then there's this Russian idea for a lander, which is at least a decade away from launch. And I don't know if it should be in the planned or proposed category. So take that with a big grain of salt. The outer solar system luck has been significantly better. Basically, we've apparently put the money and the effort and everything that everything in the outer solar system has largely worked. So Jupiter is the most visited thing in the outer solar system. Um, a lot of flybys, including some that went elsewhere. Galileo in the 90s to early 2000s was in orbit around Jupiter and sent a probe into its atmosphere. Juno currently active in orbit around Jupiter, and then oops, gotta nope, this way, this right way. JUICE stands for Jovian Icy Moon Explorer, something like that, or Jupiter Icy Moons Explorer. And the idea is it will go into orbit around Jupiter, and then later Ganymede. The Europa Clipper mission is the idea to put an orbiter around Europa. And Europa in particular is of astrobiological interest, which we'll learn about later. Dragonfly is a mission to Saturn's moon Titan. The plan is to fly by Jupiter on the way there. All right, missions to Saturn all have been successful. We've had 3 flybys, and then one mission that Cassini was the name of the part that was in orbit around Saturn. Huygens was the lander on Titan. And anyway, quite successful. Titan is also of astrobiological interest. And the mission, next mission for Saturn that's far enough along, I think it's got enough funding to think of it as real, is Dragonfly, which will basically have a lander and then it'll sit for a while. And then basically it's a little helicopter like drone. It'll pick up, it'll fly around a little bit. And the Titan has a significant atmosphere, and then land and study some other space. But we're at least 7 years from launch for that. Rest of the solar system beyond Saturn, not a lot. Voyager 2 flew by both Uranus and Neptune, the only mission to do that, but has quite successful. There are some proposals for what maybe else to maybe put an orbiter for either one, but they're not very far along. And then most recently, New Horizons flew by Pluto, and then another small object, which has that really exciting official name, past Pluto in the Kuiper Belt, which it flew by in 2019. And anyway, nothing else is beyond the proposal stage for anything out there. And this list actually I don't think is complete. There are some failures I don't have on here, but for missions to asteroids, anyway, there's I've got a couple here with some sample returns that are currently active. Japanese one at Ryugu, and then this US one at Bennu, and then some ones in the future. That are planned, including for some nearby launches. And in particular, Lucy is planning to visit and in the process orbit successively half a dozen asteroids in this category called Jupiter Trojans, and we don't know much about them, so that's probably the most interesting one here. Although Psyche is actually a metallic asteroid, so that'll be of some interest. We don't have any close-up looks of any at any of them yet. All right, and I also have some missions to comets here, and I probably should check to see if I have anything to update here. Actually, you might have more than one. Nope, that's just it. And but probably some more planned here, and including one ESA mission that actually landed something on a comet whose discoverers' names are not easily pronounceable by native speakers of English, and then the one here on this comet called Temple. The impactor basically hit it with a big, fast projectile to see what would happen when you did. And then, like I said, for the attendance codes, we are not doing. You're not emailing them to me, but still including them. But you need to go take the quiz on Plato. So this is something I turned out. This is a proposed idea, so it's got to have a lot more funding to be planned. But this is actually for a manned mission to Venus, which when I first saw that, that's crazy. But actually, conditions in the upper atmosphere of Venus are reasonably tolerable, and you can actually get to Venus and back faster than you can to Mars. So the idea is basically to have you don't land, but then be in orbit for a while, and then maybe even dropping in the upper atmosphere on these blimp-like structures. So maybe it seems kind of plausible. So kind of see where that goes. And as we'll see, this upper atmosphere of Venus might actually be of some astrobiological interest. The surface isn't, but maybe the upper atmosphere is. And we'll have a slide about that in Unit M. All right. So that's it for this video in this unit. So remember to go take the attendance quiz on Plato, and I'll let you know when the next round of videos is ready.